Hello all, today in this video I am going to provide a continuation video of the previous demo only, that is within phishing attack detection we would have worked with RNN, and in this code we are going to work with LSTM and going to compare that how LSTM is going to provide some better results when compared to this how LSTM is going to work with this email phishing attack detection, and also we are going to give an comparison. So for that initially we are making the libraries which we are needed, then we are loading the data set. This data set we downloaded from Kaggle. You can just give us email phishing attack detection the data set download in Kaggle means you will get this data set, and we are getting the data of this data set, and it is having nearly three entries like unnamed email text and email type. Within this we are going to make use of email text and only email type, and also we are checking whether the data set is having any null values. You may notice that the data set is having some null value, so in order to delete it we are using the filna function, and also then we are using the count label encoder to pre-process the data. So we are declaring the x data and y data. X data here it is termed as text, and y data it is termed as labels. Within the text we are declaring the email text, and within the labels we are declaring the email type. Then the label encoder is declared, and it is going to convert or pre-process this labels variable, that is y variable. Then since the labels variable is considered as the y variable, it is tend to have the different categories like safe email and phishing email. So this is the optional one only. So if you are interested means you can just give this like I'm just giving an plot like which email is having some high counts. So here from this graph you may get that when compared to the publishing email, safe email is having some higher counts. Then we are determining the variables like xtrain, xtest, ytrain and ytest by the use of the train test split function, and with the variables like already we declared no, which is text and labels, which we are using here, and the test size we are giving as 0.2, that is 20% will be declared for testing and the remaining 80% will be declared for training. And then previously with the labels only we used the pre-processing function. So now we have to convert this xtrain and xtest to integers. For that we are using the tokenizer. So tokenizer is applied both to xtrain and xtest, and also in order to check whether it is having uniform length we are providing paired sequences also to this variables xtrain and xtend test, and this is only used within the RNN and this LSTM model. Within RNN, we have compared with some different or different layer or organizations which we have discussed in the previous video. So in this video, we can just view a quick overview of that. So within RNN, so these are the layers which we have declared. First is sequential, then embedding, simple RNN, then dropout, dense optimizer. So we have worked the same RNN without using this dropout, then without using this learning rate, then modifying this dropout. Likewise we have tested, and here you may notice, so here we have not using this dropout, and here we are not using the learning rate, that is some user defined learning rate. Here we are working with a different dropout rate. For everything we got some difference in results, and it was given in the previous codes. You may previous definitions or previous demo, you may just check it out for if you need it means. Then in this demo we are going to work with the LSTM. The layer description is same only, but previously we are replacing the simple RNN layer with the LSTM layer, and the LSTM layer takes the units as 100. Then all others the same only. We are compiling the model by using the Adam optimizer, and we are declaring some learning rate, user defined learning rate also. Then this is also run for nearly 10 approaches. Here you may notice, so at the 10th approaches we got some better accuracy only, that is 96, but it is still less than validation accuracy is still less than accuracy, but not as much. So only 2% something is differing. Likewise, the loss, when comparing this loss, validation loss is also high only. So we are making some comparison a plot to just check that which model is providing better results. So here you may see the LSTM model is better both with accuracy and loss when compared to this RNN. In the next video, we will be working with some other deep learning algorithm and will make a comparison that which deep learning algorithm is providing better results with this particular data set. Thank you.